All
right, good morning.
Good morning.
Wait, no. Good afternoon.
Good night.
Good afternoon?
Good night.
I
woke up at 11.
Yeah, it's the first day of class. All right. I'm not posting the link on Canvas. You're adults. Okay. Cool. Did anyone miss that? Okay, cool. All right. Today we're on Derust, and the course evals 2 to 3 years ago said you all wanted slides, and they haven't said a thing since I started publishing both slides and blog posts, so I don't know if there's a preference there. The only thing my course eval said, and you'll find this hilarious if you add me for CS 151, it's weird that Calvin said we should hate classes and then gave us an assignment where he had to use classes. But is that my fault? No, because the assignment was to learn why classes are bad, right? So I'll be more specific next time. So POV, you're Alan Turing, right? We've all been there, right? And there's like Nazis or whatever, unrelatable, so we can't imagine what that's like, right? And so you like have to defeat the Nazis, right? Do you use classes or do you use lambda functions, the thing you invented? Or, I mean, Alonzo Church invented them, right? I'm just saying. Anyways, it's good that you all know how to use classes. Yeah.
I'm obligated to teach my students to use classes.
I'm also obligated to teach my students to use classes. No, so I taught them to use classes, right?
You just also taught them to hate them.
Yeah, no, we intentionally teach them wrong as a joke, yeah.
There won't be any classes in this class, though, right?
Well, that depends on how you feel about certain things. But anyways, I've been working on implementing an XOR list without you. So, like, I don't think we should use methods. I don't know where we draw the line on that.
I mean, this is why you need to be.
Wait, you're in this class?
No.
Oh, you're just hanging out. Okay. It's always scarier when there's people that's not in the class because I can't threaten them. All right. So, welcome to OS and Rust. It is the most famous systems topic, which is operating systems. The next most famous is probably compilers, but might be servers. And then, like, no one knows what fourth is. It's probably databases. It might not be databases anymore. And then there's some questions like, hey, should we still teach servers or we should just teach MapReduce? I know what I think, which is MapReduce is awesome. Because why? MapReduce functions, not classes. Boom. Okay, and so, anyways. Wait, are you teaching that?
I was going to go over, like, iterators and, like, functional, like, MapReduce functions in Rust.
Okay, that's good. I was looking at the XOR list implementation I found uses map for some reason, probably because you map over things. I've never actually implemented an XOR list, so I'm going to try and get it done before I assign it to you. Okay, so this is the best systems topic, and it's the best topic in the best language. Everyone repeat after me. Rust is the best language.
Rust is the best language.
You're hired. Good job. I was on LinkedIn the other day, and someone was like, we should hire people that teach Rust. Something like that. I don't know. And then someone else was like, but we can get the AIs to translate C to Rust. And I was like,
oh, no.
Who wrote the C? And I was like, who wrote the AIs? And I was like, did you check the Rust? And they had done none of those three things. Your action items are to access the course webpage. You're to join the Discord. Am I making my own Discord for this class? Absolutely not. That's what the department Discord's for. I suspect, as we speak, Jimmy is creating a channel just for this class or something, right? And some of you may be thinking, I bet I can use Windows in this class. Are any of you thinking that? Good. Okay. So you can use Windows subsystem for Linux. Now, for some reason, I'm not allowed to require you to run Linux on Mac hardware because it, like, doesn't work or something.
Well, it only doesn't work if you have an M3 or higher, though.
Really?
That's all I'm saying.
So, fun fact about the M3s, I haven't been able to get the Bloodborne emulator to work on it. So I thought it was like a modern device. So my brother's like, hey, I want to play Bloodborne on my computer. I was like, no problem. It's an M3.
You've been able to dual boot on a Windows for years.
Yeah. So anyways, you are required to have access to a Linux or Unix-based system. If you're using FreeBSD in this class, that's fine. I don't expect you to. I expect you to probably be using Windows subsystem for Linux too, or Mac. If you need help setting that up, Jimmy would love to help you.
Oh, yeah.
you need to set up Rust. There is a link to how to set up Rust in the first lab. It's not that hard. You just run one command. And then you need to know how to use Git. And as you know, Kara and I have taught you Git in CS 151, so you know that already, right? Yeah. Okay. The first homework is to implement word count. I thought I would assign you a command line utility. The Rust book wanted me to assign you grep, which is like a lot. So I did word count. Why did I do word count? So, fun fact, I was teaching a class last term. They let me teach last term, too. And I gave an assignment that some people said was too hard to my college colloquial class, which it had a minimum word count. And the students in that class thought that it was not possible to check the word count of documents on a computer. And I was like, that's actually, I don't know why you would not think that, right? Like, it's kind of like a goofy thing to check, right? So your assignment is to implement word count. It seemed not that bad to me, but it reviewed all of the things that I wanted to review. That is due Friday of next week. I have 2 of these open? That's crazy. So the way I set out this semester is I yap on some of you. So you've had me before. This is the convergent evolution towards this. I yap on Mondays. You talk to each other on Wednesdays, and then on Fridays, you have those 90 minutes to work on the homework. Now, there's a special announcement coming that you're actually going to be busy on those Fridays, so I hope you're available then, and if you're not, we'll figure it out. But there's also, you're all going to be talking to each other on Fridays. And so what does that mean? Well, if I teach content on Monday, that's today, it seems unreasonable to have homework due on Friday, because surely these ingenious ideas, you want to sleep on them at least one night, right? And that one night is the night between Monday and Wednesday, which is a single day, right? And so then on Wednesday you come in and you get a sort of a smaller assignment in class, and we can work all of the kinks out, right? And then it's completely unreasonable to have something due on that immediate Friday. Maybe I can make things due on the next Monday. That didn't really make sense to me. So what I do is I teach this, but actually these Fridays are sort of all slid down one. So I think of this as the assignment being released on the Friday after the lab, and then being due 1 week after it's released. In practice, you can start on all of them early. And if I'm doing uniprocessor scheduling of tasks, what is the optimal algorithm for deciding which task to work on? Earliest deadline first, right? So you just go to this column and you work on the earliest one that you haven't finished. And if you complete them at a rate of 1 a week or higher, then you will finish them all on time. And that's provable, probably. I've actually written that proof. Okay, so do Friday of next week, but just do them earliest deadline first. What are we doing today? Okay, I have to teach course logistics. I have to talk about what systems are, what Rust is. I'm going to do the course sketch, and then we're going to Derust. I thought Rust Derust was a great name for the first class. I don't know if you all think that, but I that's great. And it's fun because the Rust in the language apparently is not named after iron oxide. My name is either Calvin or Professor Calvin. I have a math degree, and then I have 3 fake degrees, and I use they, them. I do have a PhD. This feels more relevant as the classes get harder. Like in CS 151, I sort of just tell people I have a PhD, and they're like not really sure what that is yet because they're like 19 and they just finished taking AP psychology, right? And then you're teaching data structures and you refer to big O notation, and everyone just assumes you're a genius, right? Because they've never seen Greek before, right? By the time you're implementing an operating system, you really want to know what you're doing, which is why it's unfortunate that I'm the one teaching it. Okay, yes. What? I know what an operating system is.
I know you do. Then why are you saying it's unfortunate you're teaching it?
They look kind of hard.
You've done it before.
No, I haven't. No, I've implemented modules. I've never implemented a full OS because like it takes so long to do it in C. So I was waiting until I learned Rust.
Oh, yeah.
Lecture Monday, lab Wednesday. I don't know if I should call them labs. I'm calling them labs. Homework due the next Friday. There will be an in-class midterm. I love my in-class midterms. I don't know if you all like them. Why are you shaking your head? They're fun.
I love them so much.
You love them so much. You're like, dang, I love.
them like
I love those midterms. I can do 2 midterms.
Yeah.
We could do a midterm every day. We can call. Okay, wait, no, I was ready for this. You get to think of every single lab as a midterm if you want.
That's so frightening.
Right? Yeah. So I think that, like, the stress response will just wear off after a while and you won't feel anything anymore. Okay, yeah, all right. Adaptation? You should all meet on Friday, I think. Yes. OS classes are so easy to, like, deal with projects in because your job is to write an OS. So you have to have written an OS at the time when the class is over. If enough of you fail to write an OS, then it's my problem. If enough of you succeed and you're not one of the ones that succeeded, that's your problem. So, an obvious thing to do is to unionize. Your voices have been heard. These are exact quotes from either course evals or conversations in my office that I did not get permission to share. I think failing my systems class was the best thing that happened to me. This course demanded strong self-motivation, thus I didn't learn as much as I might have if grading mattered more. These are in response to the ungraded version of the class. Not to worry, this semester there are grades. I know you love them. So I'm going to use specification. We're going to try that again. Specification grading. How does specification grading work? I'm going to provide some large number of assignments. The assignments will include the labs and the homeworks. You will complete the ones that work for you, which is going to be a lot of them, but not necessarily all of them. And then you're going to get some high grade. And you're going to do things like, hey, can I turn in this late? No. You can turn in the final on time and then get an A no matter what. So that is the late homework policy. And what is this? What is that? That says 90%. That's less than 100%. So if you turn in a few things late, or they're very wrong, or you didn't understand the assignment, or you got influenza, that's fine. Yes.
What's the threshold for compiles? Like the whole world compiles too.
Yeah, so that is completion credit. So if you turn in code that does not crash my computer, that's fine.
We're going to turn in Hello World the whole class. We get an A. Everything class, because you get 90% of the homework compiles.
Yes, yeah. If you turn in a non-zero effort on everything on time, you will get an A.
Is Hello World zero effort?
I don't think it's so okay.
It's in their skills program.
Yeah, so I was aware of this form of attack on the system, right? My sense is you're very unlikely to get everything in on time if you're only doing Hello World and compiling. And a considerable portion of the work of this course is getting something in by deadlines. And actually generating code, and the code not having stray and loose characters in it and stuff. Why do I think this? I have had a real job. And my impression is that this would have gotten you promoted as well. So, yes, code compiles means it has to be legal Rust. It does not have to meet spec. There's strong theoretical computing reasons for not defining how close it has to be to meeting spec. So, the sort of more totalitarian way to do this would be compiles is worth a C or something. Why do we not do that? Well, you can just look at the average grades at this university, and I want the grade distribution I want. If grades can go all the way down to F, basically. So, and this has happened. Some of you have been in other variously forms of graded classes from me. So, I have actually published, and you can find it on my website, the CS151 final exam I use, right? And what happens is I administer that final exam. I see what students turn in, and then I just set the curve. And sometimes that curve results in turning in something with your name on it is worth 60%. And that's okay. Because there's usually a few students that don't turn in something with their name on it, and they need to be encouraged to do that. This also means if you crush the midterm, you can be pretty well off. But, midterm meeting spec is non-trivial. That means you know what you're doing. And then I just have sort of cascading percentages down. Now, you should all just plan to be in one of these two bins. And so none of this should affect you. Okay. I do like these may earn degrees. labs are pseudo-graded. You meet spec or you compile. Why is this? I do not expect you to meet spec on every lab by the end of class. That seems ridiculous. I do want to give you credit for it, and I also don't want it to adversely affect your grade, right? So I'm giving the relatively high marks for getting legal code turned in on time. I have become a very big believer in getting something turned in on time being a good metric for success, and so the grading policy reflects that. Homework grading. I'm going to try and provide either auto graders or example usage. The auto graders are getting really, really sketchy at OS level stuff. Since for an OS to be interesting, you're like not supposed to assume there's like a standard library or that it's like running on some known form of hardware or something. A lot of the projects I've looked at so far, I don't really feel good about writing an autograder for, but I provide example input-output. And so I'll just check if it's the same, but it won't. I'm not going to like write some complicated bash script that automatically checks if it's the same. So we can think of that as an autograder or not. I can show you one example. So you write your own word count. There's a system word count on your Linux system. It does something. You write your own. You build it. You run the binary. This is kind of equivalent to cargo run. I wanted to show the same forms of arguments, and then you should get the same result. Now, okay. So, what design decision did I have to make here? Where'd it go? Oh, it's nowhere. Okay. There's white space here. What is in there? Let's see, what's in here? There is an AI.html. Okay. So, like this white space here, there's no way I care about that, right? And so, should I write a script that checks to see if the white space is the same or does some fuzzing on white space? I didn't really get into that. So what I'm saying is it has to do the same thing as WC. But okay, we can check what WC does, and it doesn't say anything in particular about white space, right? And so I'm going to try and give you a little more flexibility, and I think I can do this because wait, my computer's not muted. That's why there's those beeps and boops.
That's the GNOME terminal sound for like.
The GNOME.
That's how it's pronounced in terms for the GNOME project.
Even if it is pronounced that way, we shouldn't pronounce it that way.
Morally speaking.
Yeah, it's wrong. Morally, yeah. So, anyways, there has to probably be like some white space here, but it probably doesn't matter how much. So that's an example of why I didn't give an autograder. And then this becomes a little more sophisticated when you see the full CLI, and I have more lengthy things. So what's going on here, this is the help prompt. I just closed the terminal. Why am I like this? Typing is hard. Okay. I'm not going to check that your word count says exactly this because you're not GNU core utils. So just like do something. And so that's. I haven't decided the degree to which I'm always going to have or never going to have autograders, but I think this sample input output where like if your code does this and you're not cheating by like hard coding it or something, right, then it's fine. So that's what I think I mean by autograded this term. We will see as we progress through the class, but that's my impression. So A is passes autograder, B is on time and compiles. Yes, hello world compiles. Turn in something on time. And then F is otherwise. Okay, final. Create, document, and publish an operating system. This says in Rust, I will totally be okay with you if it's in C. But I am not allowed to say that while Jimmy's here. And also, if you do this in C, I don't know what you will have done all semester, but you will objectively have learned all the learning objectives. So I don't really know what to think about that. Yes, you can use Zig.
Well, what?
Oh, sorry. What was your question?
Oh, is C++ okay?
If you
That's
use
the
the
one
same
answer.
C++ dialect as Fuchsia,
As what?
the Google Nest OS.
Oh,
They use a Hermetic C++ dialect, and so the restriction is it has to be a systems language that a real OS is written in. So there is a C++ dialect that is legal, and you're responsible for figuring out which one it is. Okay, but you're not allowed to use classes.
Okay.
Okay.
No, I just don't want to implement vectors because that's stupid.
Ooh, I don't know how I feel about that. Implementing vectors is like one of life's great pleasures.
Well,
What's next? You don't want to implement your own matrices?
yeah.
Okay.
Wait, are we doing that in this class?
No, I did. Well, we could argue the XOR list is a vector. Okay. Your requirements are freestanding binary with false exceptions, interrupts, and memory management. Late work policy is no. AI policy is sure. Collaboration policy is I can't make it mandatory. I have seen relatively few cases of this, but I'm going to point it out to you because I think it's like actually an issue of cognitive bias and not intent. I have this problem more with mathematical proofs than with code, but there will be examples of other code that exists that other students have written or that is published online or that I give to you that will solve the problem you are working on. And there will be a temptation to say, I attended lecture and I mostly paid attention, even though I'm doing really well on chess.com right now and had to get a few games in quickly, right? And then, I found this code and when I look at it, it mostly makes sense. Now I'm not sure about that one line, but I'm sure I could figure it out. That's going to be my solution. I want to encourage you to not do that. And so if you don't understand it as well as code that you write yourself. Now, how well do you understand code you write yourself? That's a little bit up to you, right? But whatever process you go through when you're writing your own code to meet some spec, you should do that for code that you don't write yourself. So if, one way to think of this is in terms of an oral defense, right? So if I brought you up to the front of the classroom and was tell me how you decided to write this line of code, it should be indistinguishable whether you wrote that line of code or whether you borrowed it from someone. But it does not matter if you wrote it yourself. It only matters that you understand it on that level.
So if we're going to plagiarize, be convincing?
I wouldn't even necessarily think of it as plagiarism. It's just understand what's happening. The goal of this class is not for you to write code. It is for you to understand how things work. And we're using code as a way to do that, but it is sort of past the level of we're in a computer science class where it's really I just want you to understand the science of computing, and we have no really graceful way to do that without using code. Sections. This term we will have sections. They're going to meet Friday from 13:10 to 14:40, which is the same time as this class. They're meant to help you unpack learning in class, so the things I say. I had a very lovely student in CS 151 2 years ago that said, I don't actually understand anything you say in class. I just come for the performance art, and then I teach myself from the slides after class. That's fine. Go to your section and make sure you understand. I don't care what you do. And also to work on homework. There is a single section leader, which is Jimmy. This is Jimmy.
Hi.
If you miss more than 4 sections, you drop 1 bin on specification grading, so that's A to A minus. And Jimmy or I are both allowed to excuse you from that, but you're not allowed to bully us to get out of it, right? Now, if you turn in an OS that works, did you have to go to sections? No. Are you going to do that without going to sections? Maybe. I don't think so. I might have to go to the sections, so I might see you there, right? So just make a good faith effort to go to these. We don't have any sort of formal system and arrangement because this is the first time we've taught this class, so there's no one that's already taken this class that can serve as a section leader. So we're just kind of making Jimmy do it, and it'll probably be okay. Is that okay, Jimmy?
Yeah.
Do you have any comments for the class or group?
Please go.
Is it going to be here?
Yes.
Okay. Are you going to take attendance?
Yeah.
Okay. There will be attendance. So there will only be attendance taken in the
I can't
sections.
say what will be done with that attendance, but it will be taken.
Yeah. So we reserve the right as the teaching faculty, which means me, but also like the department generally, to do what with it is it within our power to cause you to succeed in this class. So we'll use such forms of incentives as we are capable to get you to sections if they're helping your learning. And so probably don't worry about the specific implementation of that. Just go to the sections if you can. And if you have like some legitimate reason you can't make it, that's okay, right? And I'll be able to tell if you had a legitimate reason because I'll see your OS at the end of the term, right? Okay, so some of you have heard various paraphrases of this lecture over time, but I've been teaching now for a while, a couple years, and my sense is that some things are easier to get students to understand than others, and I don't know if that's because I'm good at teaching things or because students are good at learning things, but my sense is that references and recursion are way harder than everything else. And references are kind of the operating system topic. Recursion, I don't feel like there's like a great way to teach that. I sort of learned it by doing induction, which is a mathematics thing. So I'm going to say the math department's responsible for recursion, and I'm going to teach you references. You have probably seen recursion at least in CS 271 and CS 351, but like maybe all over the place. My sense is the adventure assignment in CS 151 is a great place to use recursion for the first time. You're unlikely to use it at that point. If those of you that took CS 151, there's a checkerboard assignment on Carol at the beginning of the term. That has a very good recursive solution. So recursion's been like around forever. But references are impossible. There's just like, there's no graceful way to deal with them. They are one of the first areas in computer science where actually underlying physical limitations are sort of bubbling up to the level we have to deal with. And the fundamental way I've always tried to explain this and impression upon all of us is that if a data type can be arbitrarily large, nothing works. And the value of nothing is namespaces. So I usually use this example where sometimes you can refer to x from inside a function and sometimes you can't. In our second favorite programming language, which is what?
C.
Sorry, that's my mistake. Our favorite scripting language. Thank you.
Or TypeScript.
Is that TypeScript is like some other class entity. So we add to x. Is this what I say? Is plus equal in Python?
Yeah.
Really?
Yeah. It's plus that isn't, right?
Okay.
I thought plus wasn't Python.
Is it? No, it is
It's not.
Jesus.
Syntax error. Why have they not added that? Like, there's no reason not to add that.
Why did you delete Pi?
Because I'm not using it. You don't free your memory after you use it.
You don't need to. In Python.
In Python, this is OS and Rust. Okay.
Excuse me, the borrow checker does that for me.
I didn't realize you could have semicolons at the end of.
Oh, you don't put semicolons at the end of your Python?
You can, they just don't do anything.
That's really
Yeah. They separate.
It's just like JavaScript.
Okay.
Well, yeah, there is. So my favorite way to use the semicolon. It's when you need a library.
Error or not?
Import matplotlib
It's chaotic.
dot pyplot. Am I making this up?
I think that's the one.
As plt, and then you semicolon, and then you plt dot plot range 10. Is this gonna work? I probably have to like show or something. There you go. Right. So this is what I use semicolons for.
Okay.
If I don't want to open the interpreter. Okay. Isn't this right?
Reasonable.
Isn't this reasonable?
That's reasonable.
What? Okay, fine. So we can save the figure as, I have to use little quotes now, plot.ping. Then you close that, semicolon, of course. And then you do a semicolon at the command line, and then you open plot.ping.
That's impressive, honestly.
I know, thank you. Okay, so, anyway, okay, so, all right, unbound local error. You all following along? You got distracted by me doing data science, didn't you? Got a bunch of data scientists in here. Yeah, you can always tell. Yeah, see, we love our data scientists, don't we, folks? Let's give data science a hand real quick. Good job. Yeah. Without data science, we wouldn't have anything to use MapReduce on. Okay. So as we demonstrated, you cannot refer to a variable, a global variable inside a function, right? Everyone knows this.
You can do it if you add a global keyword, but that's just...
That's cringe. Yeah. Which means, of course, this won't work. Right. This is going to be an unbound local error. Oh no. Oh gosh. Oh, so it's occurring to me at this point in time that x must be a value, and this must be something else.
It's a list and a value.
Yeah, but like, isn't this a value?
Python's just weird.
I don't think it's just Python. I think that's the fundamental systems topic of references. Right? So because this thing is of arbitrary size, because I can throw arbitrary numbers into it, an arbitrary number of numbers into it. And in fact, I can put things in there that aren't numbers. Everyone loves it when I do this. So you can... You thought... Well, it's none. Because the return value of print is none.
That makes sense.
Yeah. Obviously.
Sure.
Yeah.
I don't understand what's confusing about this.
It's just gross. It's not.
Oh, you don't like that the list is 0 indexed, because...
Hey!
No, that's my bad.
That's fucked up.
Okay. So, I love Python, as do we all. It's our favorite scripting language, in a 3-way tie with Python, TypeScript, and that version of C++ that runs at the command line that Jimmy found on YouTube. And so, surely as computer scientists that have written code, we understand that it's not good that sometimes a variable exists in different namespaces based on the type of the variable, right? I think that probably makes sense. And this especially is sketchy in Python, because I can just change the type of that variable with assignment, and then the code might break, and then it might go back to working. And that doesn't work. Let's see. Oh, I guess I have to put it in immutable. I don't know. Like, this is it's just weird, right? And this topic should be weird, and it's good that it's weird, because we have a way to solve the problem of this code being weird. And the way to solve the problem of this code being weird is to implement the heap and page tables in your operating system. So, how are we going to deal with this? We're just going to introduce some quick terminology to get through this. And the terminology I'm going to use here is the reference and also the pointer. I've been digging through the Rust documentation. Looks like they usually use the term pointer. But I am sort of gravitating towards this idea that we should actually refer to them as... Okay. We should refer to them as keys, because it's theoretically identical to key value storage in a hash table, right? And so instead of deciding between pointer and key, we're going to say reference. So what is a reference? It's some sort of thing in a computer, And it's necessarily some kind of value because it's a computer thing, right? But it is not meaningful for what value it takes on itself. Rather, a reference is meaningful because of what it tells you about the memory system you're working in. So I like to think of the example of an email address. There's nothing particularly useful about ckdeutsch@willamette.edu. But I've noticed that no matter what advising questions you ask, if you send them to that address, eventually someone might deal with it. And if not, then that's an exception which doesn't count, right? And so that's what references are, and references are the fundamental thing that is happening here, right? Okay. Why is this important? It's important in this class because one of the most interesting things, in my view, that an operating system does is it manages references. It manages the key value storage of your sort of entire computer, right? So every executable you use, every file path, all of those things that are in your path variable, all of the executables, all of the commands, all of that stuff is managed through something that looks a lot to me like key value storage, but it's mediated by the operating system. And so when I go to my most beloved command line, which I obviously get to by opening Python, importing OS, and then in the same line saying os.system, and then providing a string to os.system. Oh, right. Sorry, that's my bad. I need to... Dang it. There we go. Oh, sorry. This doesn't quite make sense. I should say probably... You know, I'm gonna stop myself right there. Actually, I think I can stop anytime I want. Right? We'll put a little flag in there. This is how I always use the command line. But somehow, my operating system needs to know what WC refers to, and also needs to know what bin bash refers to. So, why am I not teaching this class in Python? Let's see if I can remember this real quickly. So let's see. Quarto drop. Or we can do pyodide. Okay. So it is possible to run Python on top of not an operating system. And so I could say in here and that doesn't work. And that doesn't work because this version of Python, pyodide, is running, well, I mean, it's running in Chromium. Well, no, it's not because I'm in Firefox. It's running in Gecko. And Gecko doesn't have a bin bash in it. So it isn't meaningful to do os.system calls. What, do I have to say binge?
Does it have like an SH or anything? Does it have a bin?
I don't think it has anything. I don't think it has a...
It's a WebAssembly runtime.
Yeah. What
Why
like
would it
does
have that?
does web? There's some notion of a file system in WebAssembly. There definitely is because I've written to the file system from WebAssembly, but it's a file system that's maintained inside the browser.
Yeah.
And my sense is not that there's not a file system that exists inside the browser, because a browser is in fact an operating system probably. It is that the OS module written in Python doesn't support WASM runtimes. But nevertheless, this shows a core weakness of relying on Python to write an operating system, because Python requires the use of an operating system to function, and its core utilities only function in the presence of an operating system. Now, this is true of all languages, but it is more true of some languages than others. And the other thing I was going to show you was our WASM Quarto drop, which is really cool. This gives access to another... No! Where's the demo? No! Back. And this one you can make plots in, I think. Why is it slow? Okay, so what do we do? Import matplotlib.pyplot. I'm trying to get the data scientists to like me, okay? Everyone play along. Okay. plt.show. No. plt.plot. Range 50. Look, you can do it in your browser too. Okay, so there you go, data science. Please don't tell the data scientists that I called that data science. Actually, you can. At this point, it's over for me.
Room right now.
Do we have a physicist? Yeah, okay. We've got data scientists, we've got physicists. I am detecting mathematicians, don't need to call them out. Do we have a chemist? Any other non-CS majors?
Philosophy.
Oh, yes. That makes sense.
Yes.
You heard the bit on natural and artificial philosophy, right?
I don't think so.
Yeah, so I got banned from saying that. But, right? So, never mind. Okay. So there's the natural sciences, then there's the artificial sciences, right? Computer science is the artificial sciences. And then there's natural philosophy, and then there's artificial philosophy, which is also computer science. Okay. So Rust, in my view, it could be a little more forthright about how to work with references. But here's the thing. The C programming language, beautiful thing that it is, has been around for a long time. And there's still no one that can actually write good code in C. And a lot of people have tried very hard. Now, there's good code that has been written in C by teams. The Space Shuttle flight software was pretty good. The Linux kernel, of course, is good. HTTPD is good. But no individual human has ever written good code in C. Okay, Git, the initial commit of Git is probably fine, but it's like 500 lines, right? And it's only useful because it solves the problem of it not being possible to write good code in C, right? So C was around for a while. Everyone wrote absolutely heinous C. There was buffer overflow problems. There's null pointer dereference. All of the code in the world is crashing all of the time. And so it was bad. And the good people, who are Mozilla, were like, what if instead of code being bad, it was good? And then they made Rust, right? Okay. And when they made Rust, what did they say? They said, you silly programmers, you think you're so smart. You can't even deal with null pointer dereference. We're never letting you see references again unless you explicitly say before you're doing it, what I'm doing is unsafe. And if you say the magic word unsafe, then you're allowed to do things that are bad again, right? So we're going to deal with references in Rust, even though Rust obscures references, because my sense is Rust as a modern programming language is going to provide you more help than C would when things go wrong. The point of this class is for you to understand how things work. Rust works, so it will get in your way less than C. Now, correspondingly, I do think you will learn less about how some things work. But I think at the level of this class, getting some kind of understanding of how an operating system works is a great thing to do, and we don't have to spend the entire term wishing that the C compiler had more clear error messages, which is what we would be doing otherwise. So there's going to be a little bit of wonkiness getting Rust to do things that it doesn't want you to do, right? But it will let you do them, and then we can learn the things that we want to learn in sort of a safer environment. And then also you can go get jobs because everyone's supposed to be learning Rust right now. Okay. So, okay, I'm going to say this, and all the Rust people are going to clip it. You should probably use Rust in every application where correctness or performance matters. And I probably believe that. Yeah, Rust is bitten on LLVM. That's cool. It's whatever.
What are the other applications where neither of those things matter?
Oh, all the scripting stuff. So like if you just need to make like a quick like e-commerce website for your cousin or something, and it's okay if it crashes 1 in 10,000 times, right? Like it's totally fine. So I mean, my sense is you should virtually always be writing Python or something like it. It's just suddenly if you like need to put an airplane in the sky or something, right? When I was like applying for jobs back when I thought I was employable, I applied to like a lot of like automotive and aerospace stuff, and like all that should be Rust. And then on the flip side, what I didn't apply to is like there was like a telecommunications company that like broadcast television shows to people's houses, and like 0.05% downtime is totally acceptable in that application. Someone asked me what data structure I would use to store the Bible. I don't remember why, and I was like, obviously binary search tree, right? They want a hash table, so I think good job. But so like if you're like making a Bible app for your phone, 0.05% downtime is acceptable. And then if you're making a brake system for your Tesla, well, in that case, downtime's acceptable. If you're making a brake system for your Hyundai, then you have to have 0% failure rate, right? We're going to follow Philip Opperman's. There's no way that's how Opperman's spelled. 2 P's and 2 N's? My brain's cooked. No, there's 2 P's and 2 N's. That's wild. That'd be like if my name was Deutsch-Beinen. Okay, writing an OS in Rust version 2. You can read more about it here. Here's the structure. We will proceed in 3 parts. We are currently in part 0, but we're not 0 indexing. Part 0 is Derust and unsafe Rust. I'm just going to teach 1 lecture on unsafe Rust next week, and then we're going to get into it. The homework I was going to give for that looks kind of hard, so I might do something else. I don't really, the purpose of this class is not to be difficult. It's also not to be easy, but I don't want to just assign hard things for no reason. So I need to think on that a little bit.
Assign like a normal linked list.
A what?
Like a normal linked list, not like an XOR one.
Isn't it completely safe to implement a normal linked list?
You can.
Was it not an assignment that you helped students with in the Quad Center last term?
I mean, you can do it. You can just say use and save.
Okay, maybe. I'll think about it. That seems not cool. It's not cool, Jimmy. I want to do cool things. Would it not be more safe if I wore my seatbelt when I drive? But it's not cool. That's why I also smoke. Okay, I'm not sponsored by Big Tobacco, for the record. I think that if a camel is smoking, it looks cooler than a camel that's not smoking, right? Right? I think we can all agree on that, right? Okay. We're doing okay. Right. Bare bones. The first thing to do is you compile a binary or an executable. I don't really like this tendency people have to refer to executables as binaries, but I understand that that's fine. So every program you've ever run in your life assumes there's an OS, unless you're very explicit that it's not supposed to assume there's an OS. I just showed you with Pyodide, it even assumed there was an OS even though there wasn't one and it still worked, right? And so our first task, which is sort of after the break and after we derust a bit, is to just make any binary at all that can run without assuming an underlying OS. And we're going to do that by targeting arbitrary architectures that don't have operating systems that run on them. And that's the compile, right? And so then, the week after that, we're going to realize, ooh, it's not actually super interesting to have an executable that doesn't do anything, even though it is more interesting to have an executable that doesn't do anything than to have nothing. So we're going to try and do a thing, and of course the thing you do is hello world, right? So it's going to print. And then you're going to think, wow, I sure wish I could use this thing to do algebra, right? Because we all love algebra. Right, so then we're going to do simple I/O. And then, you all heard of software? Software, like the opposite of hardware. So all these people that write software think you're supposed to test your code. Have you all heard of this? So apparently we're going to test our code and make sure it works. Okay. I know. Have you also heard of these things called comments? You're supposed to put comments in your code. There's all these rules about writing code, right? So we'll deal with some of those. Okay. Next one's pretty interesting. Once you get your sort of executable working and doing a little bit of I/O, you're going to realize it's not a very good OS. Because you can't do any of the interesting computer stuff with it. So when we say OS, it's called an operating system. Why is it called that? Well, there's some physical piece of hardware that you want to interface with and interact with somehow. But you need an abstraction layer between you and the hardware so that you can do things that are actually interesting. And one of the things that you want to do that's actually interesting is you want the computer to be able to be working on some problem And then if you type into it, it doesn't lose all of its progress on that problem, and it also doesn't ignore you typing into it, right? And you're like, that sounds easy, and it's not, right? And so we're going to deal with sort of the three big things, which are the CPU exceptions. So what happens if you try and divide by 0? And yeah, like kind of no one cares about the division by 0 example, but like, what if there's some problem? What if you ask for a number bigger than there is, right? We're going to deal with double faults, like what if you divide by 0 and then you divide by 0 to checking to see if you divided by 0, right? And then we're going to deal with hardware interrupts. And hardware interrupts are super exciting because one of my favorite subfields of computer science is real-time computing, where every once in a while someone notices that computers, even though they don't know it, they actually exist in the real world. And in the real world, things happen. And one of the things that can happen is a person can start typing at a keyboard. But like another thing that can happen is like the power can go out, all this stuff, right? And so hardware interrupts are super interesting because they're the basis of everything that computers do that's cool. Networks run over them. I/O runs over them. Are there any gamers in here? That was a trick. You're not supposed to admit you're a gamer. Okay? All right. So gamers love this stuff because they like to use their game pads and they like to yell racial slurs and obscenities into microphones, right? And you can't do that without hardware interrupts, right? Wait a minute. Maybe hardware interrupts are bad? Okay. Wait, no, you can't call your family and wish them a happy Mother's Day. There we go. That's what you're supposed to use the microphone for. Okay, I got it. I needed 2 chances. Okay. Then the next thing to do is also, this is super cool. When I was pitching OS, and I've pitched it here, I've pitched it other places as well. One of the things that I have always pitched is that it's odd to have a class that many universities do called data structures, and then to just sort of leave it at that. Because my sense is data structures are kind of easy and not necessarily super interesting. And in fact, if I were to tell you what type of data structure a page table is, you'd be like, well, that sounds really easy. And then you'd have to go out and actually implement the thing without an underlying OS, and you'd be like, oh, there's reasons that design decisions are made that impact how computers actually work today, because some of this stuff is like, oh, I understand a theoretical way to do that, but actually tricking the hardware into behaving the way I expect it to according to mathematical theory is non-trivial. So all of this memory management stuff I think is really cool because it's actually taking data structures and it's using them to create a usable computer system out of it. We take so much for granted about how computers work. Even just like, I am such a big fan of file systems. I use my file system to organize my work. I'm not one of those people that keeps everything in my downloads folder. And I don't usually think about how the file system is implemented when I'm like saving something in a place I can find it again, right? I just think, oh, this is what you use computers for, right? But the operating system has to deal with all that. Someone had to write code that deals with all those cases. Someone has to keep track of all of that. This has to be written down somewhere, and it takes storage cost, and it takes time cost, and it takes compute cost. All of those things add up, and they're all worth thinking about. So we're also going to deal with memory management, because that is one of the core tasks of an operating system. The final. Implement a minimal OS in Rust. It is individual, under version control, compiles and runs, and is tested. That seems fine. Ooh, Vim. Oh no, Indy's here. So I know Vim. I know many of the keyboard shortcuts, and I'm going to now demonstrate a few of them. So I'm going to open my terminal, and I'm going to... Hey, look, it's plot.png. Remember that? Okay.
Too late.
Wait, no, it's not too late. Oh, I should have closed that window from the terminal. That would have been cooler. Okay. Okay, so what do? We do like that list. Do you think it's EOG?
We can find out.
Is this it? Ah, stay up. Okay. No, what's it doing? No! Does anyone know how computers work?
That's why we're here.
Why is it function F11? Okay. Oh, so I was teaching understanding AI this morning, and I think like this thing didn't work. I had to teach it on a Windows device because there was a Windows teaching machine in there. I'm doing the Windows keybinds. Okay. Okay, that was it. And EOG, and then we can see that there's no. Why is there still Python running? I wonder who. I was just assuming that kill command worked. I wonder if that's the operating system that has to deal with all of this stuff for us. That'd be really interesting. I bet we'd learn about that later. Wait, I wonder. This thing can't see Firefox? Okay. Oh, right. Yeah. I was going to use Vim. What was I going to use Vim for?
So like you know how to use them.
Yes. Okay. So obviously I'm going to use NeoVim because I'm not showing my age. Okay. And then I should probably change this to an SVG. And then what I said in my college colloquium when I was teaching them Vim is the way you figure out how to exit Vim is you pop your head up and you look around the room, right? So you see, and then you see if Indy's in the room. If Indy's in the room, you do.
Did you actually say it?
Yes, you do 2 capital Z's to exit. Okay. And then if you look around and can you like pretend you're somewhere else? Okay, right. So if you look around and you don't see Indy, then you get to use :X. And it does the same thing. But if you use :X while Indy's there, you get cyberbullied in the CSSA Discord for not knowing Vim commands. There's a few other things we can do in Vim. We can go to the start of the file. We can go to the end of the file. We can delete lines. We can copy lines. And I bet this is still, I bet we can still read this. Well, we tried.
You did change to say it's not a PNG file.
You think I should just change it back? Oh no, I forgot to check if Indy was here. Sorry, here, we'll do it again. Okay, this was SVG. What's special replace mode? Capital R? There we go. PNG? Oh no, it has to be capital. I can't type. That okay, not typing should not count against my Vim skills. Okay. You look around. You look around. Double Z. Okay. Oh wait, no, I'm still in insert mode. No. Okay, I'm in command mode. Okay, there we go. It does look like this is a little bit cooked.
It's because it's still open.
Oh, okay, it's still open. No problem. Okay, so let's find it. So then we're gonna kill. I was not using Pico because it was more.
You can also kill all EOG if you want.
I'm thinking it's not. It's maybe not a well-formatted PNG file after I edited the text of the image data inside Vim.
That's possible.
So, anyways, I know Vim. I don't know Firefox. No.
Wow.
What?
I'm very impressed.
I don't know if it's F11 or function F11, and whichever one I click, I will be made fun of for. I'm going to try function F11. We're going to see what happens, yeah?
Would you be willing to provide some motivation for why we ought to use Vim as opposed to a more conventional IDE for this class?
I feel like this is just like a trust me angle. Like, Indy, do you have? Okay. The classical motivating example I always give is you're a hacker, you're doing offensive penetration testing, you gain shell access to a remote server, and you want to edit a file on the server. You will most likely have a Vim installation on that server you can use, right? Now, of course, with like most of the modern IDEs, they have some sort of protocols to get around that, right? And then the other one I always give is VS Code is in fact owned by Microsoft. Everyone got really into like Sublime there for a while and stuff. These things are under different licenses, and so you may at any time become reliant on a tool that suddenly is no longer free. And so I expect Vim to be free until the end of time.
if we happen to have already taken your crypto class, learned Vim to proficiency, and have concluded that it sucks to use when you don't have to use it,
Then that means that you didn't learn it to proficiency.
that's true.
Yeah, yeah. Do you, so, okay, I'm going to ask it. Do you use summons in Dark Souls?
Right? Yeah, sometimes.
Yeah, see, that's probably why you don't use Vim all the time.
Ooh, I play games to have fun. Shut up.
No, Vim is fun. Vim's the fun. Okay. All right. Indy, do you have thoughts? You raised your hand, right?
Well,
Did I make that up?
I've seen like a couple of times where it's like I had Nano but not Vim on like a minimal and stuff.
It will have Vi. It'll probably have Vi if it does.
Yeah, that's true. That'll probably be.
You know, my
What if I want to game?
Mix OS install it had Nano but not Vi.
Yeah, I guess I don't have a problem with Nano. If you want to use Nano instead, that's fine. So my take is learn pretty well one terminal-based text editor. I expect VI, not Vim, to be the most common one. I was told, when I took this same class that I'm teaching right now, I was told to learn Emacs, which nothing has. And the reason to do it is, I guess I've made a separate argument for this as well, that it should, over time, become more obvious to you what internal data structures your terminal-based text editor is using internally. And the process of using a terminal-based text editor will also teach you things about data structures and information management that are independently useful. I do think the skills are transferable. Right when I was starting here, one of the proposed projects we had in upper division class was actually to implement a terminal-based text editor because it's like an academically interesting project to do. I couldn't find a way to fit it in the curriculum, but I do think you're learning something about buffers and registers every time you use Vim as well, and I don't think you're learning that with VS Code. But I can't make you do anything, so do whatever you want. Derust. Okay. Here's some things that are in Rust. How many minutes do we have left? Okay, cool. Rust contains options, results, std, everything has std, iterators, closures, pattern matching, format strings, which everything has, and ownership. Okay. Sometimes code makes sense, and an example of that is if I implement a type hinted multiply add operation over numpy uint64s, which is the Rust U64 type and the C uint64 underscore T type from standard int. This will take 3 uint64s and produce 1 uint64. It's possible to demonstrate this. I don't know that we care. And you can get mad at 3, 4, 5, and that's whatever that is, 23, which is the number of chromosomes?
Yeah.
Chromosome pairs.
Yeah,
Chromosome pairs.
Hopefully.
It's the number of buddies. It's
Yes.
the number of friends. And like the nice thing about this is that like if I put positive numbers in there, I'll get positive numbers out. Right. So this is a good way to deal with a restricted subset of the numbers, and then you have to actually give some thought to what restricted subset of the numbers is. So sometimes you're mad, and sometimes you're MASU, because the AD in MAD stood for addition, and the SU in MASU, which stands for Metro State University, which is university in Denver, Colorado, that primarily serves a veteran population from the military installations out there. They're not hiring right now. Not that I would want to leave. Whew. Okay, all right. So MSU stands for multiply, subtract. And this is a sort of combined, more sophisticated operation that is supported by some computer architectures. And this is fake because if I take unsigned integers and I only put unsigned integers into this thing, I can get negative integers out of it, which is super bad. Oh no, that's not a uint. It clearly has a sign, right? So how should I deal with this? Well, This might be a slightly motivated example, but I need to check to see if my result is going to be negative. Because if it's negative, I can't fit it in a uint, so that's no problem. We'll just put in a little bit of case analysis. Maybe if I were using like a cool programming language, I could like pattern match or something. Yeah, anyone like pattern matching in here? No, we haven't introduced pattern matching yet, so we don't like it yet. Okay, and so then we hit the 3, 4, 5. Wait. Oh, there's a plus in there. Do you see that? I'm a failure. There's no graceful way to edit this. I'll have to open a new tab and open Vim. This is stressful. Okay. No. It's been a while, okay? How do I select all?
Yeah, use Vim.
Yeah, I am.
It's great and teaches you a lot of things.
Are you not learning from this?
If you want to see someone who knows how to use Vim, you can show up on Friday.
I know how to use Vim. Wait, how do I copy this?
What?
I thought you used Helix.
I do, but it's basically the same thing. The key bindings are almost the same.
No, that didn't get it.
Definitely look like this. So.
Wait, no, okay, I have an ingenious plan. I'm going to save this. Wait, no, I ruined it again, right? There's an R there for some reason? Okay. Okay, what do? We look around, okay? And then double Z. No, I didn't save it. Okay, so we're gonna save this as file.txt. We're going to cat file.txt. Then we're going to copy that.
You could have saved it as a Python file.
Why would I do that?
Doesn't matter.
No, just could have done that.
I don't. Well, I didn't know what my path was over here. Fine. Okay. Import OS. Does this work? I don't even know. Okay, I guess I could have. Okay, we'll save it as a Python file. Move file.txt to file.py. Okay, import file. No, from file import star. Okay, and then we're gonna MSU 345. Easy, right? So it's wait, that's.
Did you delete the old one?
Wait. Is this actually correct? Okay. I really don't expect that to be negative 17. Is the math wrong? Anyways, moving on. So, what you should do if this happens to you is you should use in Python apparently. I don't know anything about Python types, but I think you have to use a union type to return either a none or an integer. Does that sound right? Okay. And then you have to add from typing import union and all this other stuff. And this is a good way to deal with error handling, so you don't have to live code in some combination of Vim and Bash in front of the class and be humiliated. By the way, my job, I'm a professional full-time entertainer, right? I don't actually write code. Okay, so you're not allowed to judge me. That's not true. You are allowed to judge me. Okay, and so we've got this. And then, do you ever wish there was a nice way to handle a union of none and x for all x? Not to worry, folks. There is. Just switch from your favorite scripting language to your favorite programming language. Yes.
I don't know what a union of none and x even implies.
It can be either none or the type. So given some type, we'll go back. Given some type, this function can either return that type or none.
Sure.
But in order to offer this for all possible types, then I have to declare the union of none with every possible type. And so, by pivoting to Rust, I have this option where I simply specify option over some type. And then I can either have some of that type or none. Oh, wait, were you not in Rust class last term? Okay, that's why. This is new for you. You got it. Good question. Okay, that's option. Results are basically options that incorporate error handling. These are like super popular in systems programming, as far as I can tell, because people always want to say what went wrong. So I guess the latest Linux kernel edition is 6, which means that if you have something that's checking the Linux kernel version, it needs to make sure the value is less than 7, which we're storing in a U8. Why? Linux is so old that it was originally implemented in 8-bit, so that makes sense. So what do? We return either a U8, which is the Linux kernel version, or we return a string. This is a static string, so this is not one of those owned strings. And we say error, not yet released, and this is just a string literal, is a string literal of fixed size, so we don't have to jump through any of the hoops we have to jump through when we're dealing with things of arbitrary size. This is a common pattern that you should expect to see in a lot of code. This is the same as null checking your C system calls if you are coming here from CS276.
So it is, I'm still going back again, but it is literally just the same as like type hinting a function, except it could be like, it will be this or maybe this depending on some checking we will do it in the function. Cool.
Yeah.
What if it's a third thing?
Then the type check fails and the code doesn't compile. And then you get a 0 on it, even if it's just hello world. Okay. Oh, should I demonstrate this? I can do that. Oh, what's today's date? I almost wrote 1423. That's the time. It's 1:12. Oh, that's right. You're not allowed to do that. Okay. That will work. Okay. And then what was I going to check? Oh, we're just going to debug some things. Why is this not syntax highlighted? Does that look odd? It's not, right?
Yeah, the function is highlighted.
Yeah. I don't know. Okay, well. Or we'll take all of it. What is that?
Probably why it's not syntax highlighted.
That's probably why it's not syntax highlighted. What character is that?
I don't know if
Here.
it matters.
You see that? There's some kind of character there.
I didn't sin.
Yeah. That's wild. That's cool. All right, well, the more you know. Wait, no. I almost did :X. What do we do first? You're on?
Look and see if Indy's there.
Let's see if Indy's there. Indy's there. Double
Let me
Z.
think of :WQ.
That's
That's
what I
fine.
do.
That's also what I learned.
Yeah.
I do :WQ still.
I really don't like hitting Shift and Z. They're like right next to each other. It overloads like these fingers on my hand, right? WQ, that's nice. You're like everywhere. You're right. Like it's WQ up here.
I can do it as fast as I can. Z, so
Sorry, did someone say something about as fast as typing? It's time for monkey type. Okay, sorry. We have to do a quick monkey type break.
make it Rust though.
I don't know. I actually don't know how to do that. Is it custom?
It's somewhere in the menu, right?
And then you can click on the language, I believe.
Which language?
Like above the typing area. See how it says English?
Oh, I did not see that. I did not even perceive it.
Whoa!
Oh, well then just do. Well, instead of
Well, that's because it's a custom. You need to go back to what it was. Go back to like words or time.
time, yeah.
Go
I'm gonna
back to time
refresh
and then
this.
go to Rust.
Okay.
You're still custom.
Time. Wait. Okay. B tree map. Ugh.
Yeah, from standard. B-tree map from standard collections.
We know about B tree map because we used them in the thing we published together that you never gave up to talk about. Well, the cursor jumped forward, so I didn't know what to do.
Press space.
I pressed space? No, you're falsely accusing me of things I didn't do. Ah! 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 Wow, Rust is hard to type. Oh my gosh. This is a terrible language. Why don't I teach Python?
Union. That's like,
We just taught Union, okay? Don't pretend you don't know
no,
Union.
Like, when you, I've never, that's the only one of these I've ever used, I think.
Actually, yeah, these do look super common, don't they? I mean, obviously I don't use traits, but other people do.
What's the difference between :SZZ and WQ? May I share? Is this
Yeah, go for it. I'm stun locked, obviously.
:S and ZZ are implemented the same, and WQ, or they both, if the buffer is different from the file, then it writes, and WQ always writes.
50 parts per minute.
So you're saying
I'm getting owned here. Oh my gosh, I'm only 40% done.
Better?
Path buff?
If you wanted to, for some reason, keep a log of the last time you looked at the file instead of editing it, then WQ
But
is
doesn't your
easier.
operating system already do that?
I don't recall.
Depends on your operating system, and you're having to implement your own this term, so you'll get to make that decision
Mine
yourself.
won't for the.
Or I guess that's your file system.
I don't know if we do files
If
because
I
we
remember,
did that point in this class.
setting
That's why mine won't.
File
Wow.
systems are hard. File systems are
Yeah,
hard.
yours
I've been
is
working on
6
DHT2,
megabytes.
my file system. It's a lot.
Okay,
The blocks can be
what were we doing? Wait, did this work? Okay, and then you can either do cargo run or cargo R, and how do you decide which one to do? You look around the room, see someone? Okay, then you do cargo R. Okay, look! My code that I wrote.
Well, big.
My code that I wrote, myself, can either return something that can be a valid Linux kernel version, like 4, or I can say that a version is not yet released if I provide too high of a number. So I can see it is either okay or error, yes. And this is the basis of Michael Jackson's hit, Smooth Criminal, which begins by asking, Annie, are you okay? Because okay, and no, Annie is a results type over names. Results. Options, results, and more fun things like vectors are all part of std. And fun fact, I wrote that, and then I was like, I should see what Rust says as part of std. And they literally list vector and option as like the two things, which is wild. So like, I guess there's other stuff in here. But basically it's vectors and options and printing and stuff like that. Oh, I guess I should say this because this is an OS class. All of that stuff, or you're able to use portions of that, but not all of it when you don't have an underlying OS, because printing won't work, because printing is going to throw something to the terminal. The terminal doesn't exist, but vectors, if they're implemented internally in the standard library, let's use them. So iterators are also a built-in Rust feature. We love iterators because our favorite scripting language is Python, and it reminds us of the Python for each loop. I think it was always sort of non-obvious to me that there's kind of a lot of lazy evaluation in Python. I think you can do this. Is it r.next? Okay.
It's gonna be like some underscore or something.
Yeah, well, what's actually saying is range is not an iterator, which I thought it was. So what's an example of an iterator? Is this one going to be an iterator? Okay, that's allowed. Okay, so you can write iterators with whatever this notation is. That's not a list comp. I guess that's like an iterator comp or something.
Tuple comprehension.
There's no way that's called tuple comprehension, right?
My dad.
Okay, so we're going to use Python tuple comprehension to write an iterator.
I reckon you could have also just used list comprehension.
Well, then it's not lazy.
Are tuples lazy?
No, this
Clearly
is
it is.
no, this is not a tuple. This is a different. It's
Clearly it is lazy.
yeah. This is how you write lazy list comps, but I don't know what they're called.
Generators?
Yeah, generator Python. There you go.
Is that just a generator comprehension?
Yeah, it's a generator comp.
Oh,
Probably.
yeah, that makes sense.
No, it doesn't. It looks like a tuple.
Well,
No, it looks like a tuple.
no.
It's tuple.
Python syntax was designed to please exactly one person. So,
And that person is very pleased. Okay, so you are familiar with vectors because you're familiar with Python. The only difference here is that this, because Rust, a lot of people don't know this, Rust is the combination of JavaScript and Python. That's why we have to say let. And so this is how we loop over an iterator in Rust. So if you haven't seen a Rust loop before, this is a loop. If you're coming here from the C class, we have the Python for each loop in Rust. You also have the C loop, but no one uses it. Okay. The C looper, as I like to call it, the kloop. Anyone like kloop? So up in Portland, where they keep me, there's 2 streetcar loops. There's 3 streetcar loops. There's the NS, which goes north to south. And then there's one that goes clockwise and one that goes counterclockwise, and one of them is called the A loop and one of them is called the B loop, and I call them the A loop and the bloop, and everyone hates that. So if you're ever up there, ride the bloop. Think of me. Think of me. Blooping ain't easy. That's what they say. There's Rust closures. This is very similar to Python Lambda. I don't really love this syntax, but there's a lot of Rust syntax I have opinions about. Where I expect you to encounter this is I expect you to look for help on the internet and see closures floating around. And when you look for help on the internet and you see closures floating around, this is what you're looking at.
we also go over them on Friday.
We're also going over them on Friday. Why? Oh, for mapping?
Yeah.
Okay, never mind. You'll learn closures right away. Okay. Pattern matching is awesome. This is probably my favorite Rust built-in. And so the way pattern matching works is it's basically, it's a compressed way to write if statements. It's similar to the C switch statement. But because Rust has such strong support for the option type and the result type, it is very useful to have the match expression, which you can apply to some value, and you can unpack that value conditionally on whether it is something or nothing or perhaps an error, right? And so this is kind of cool. So we create an iterator over the characters in Hello World. We take the 11th character because we take nth 11. This is the same thing as saying next 11 times. And if we have some character there, we will print out what the character is. And if we do not have a character there, we will hit a none, and then we can just print out an error statement. In general, my sense when writing Rust, and also when looking at other people's Rust, is if you're writing if-else statements in Rust, that's usually unrustic. They don't say rustic. What do they say? It's not Rust-like either. There's Pythonic. What is...
Idiomatic. Idiomatic Rust is usually the term I hear.
People say idiomatic Rust?
Yes. I don't like it either.
We're going to say rustic,
I like
think.
that a lot better.
I think that's much better than idiomatic. If-else is unrustic. If things aren't rustic, then you can't overcharge tourists for them in your resort town, so write rustic code. Okay. String formatting is cool and fun. You've all learned string formatting F strings in your CS151 sections and probably some other people or other places. If you're coming from C, this is printf. If you're coming from Rust, it's the same. I did not dwell over long on format last term because usually used println, but it's the same thing. It's the same syntax, and this is awesome, and this is going to be very useful for us this term. I have 2 extended examples that I'm proud of, even though I got some negative feedback about some of the design decisions from people that are like a little bit of Rust snobs that work at the Quad Center. But I wrote a hex reader and a Fibonacci calculator, and I think these are great. So I think if you want to just like look at Rust and click through as sort of like a narrative example of how I use these things. So here, for example, we have an if statement, so that's not rustic, right? And then here we have the Fibonacci dynamic programming example, which I think is pretty cool. Ooh, those lines broke. Take a look at that. So I have sort of teased a few of the Rust features that we're derusting this term. I think these are 2 good examples to go back over them and make sure you're familiar with the language. If you ever want to get back into a language or into a language for the first time, a great way to do that is just write a few simple scripts, and these are some examples, and then the lab will be WC, which is going to be another simple example. So go ahead and take a look at these if you want to review on Rust. Okay. Those are the Rust features, and then there's one big scary one, and that's ownership. Ownership was nominally the thing that was going to make Rust good. I have articulated this before. Rust deals with memory differently than every other existing language. The way it deals with it is called ownership or the borrow checker. When I was told I should start getting excited about Rust, everyone said, oh, it has the borrow checker. That's why you should get excited about Rust. I don't believe those people at all. What Rust actually has, it has option types and pattern matching, which are vastly more important. I think option types and pattern matching reduce far more errors than the borrow checker. That said, all of this stuff put together is designed to make a language where it is harder to write bad code than it is to write good code. So, the borrow checker or ownership model is going to push you towards writing code that doesn't explode. The way we think of this is I think of it in terms of size. A byte has a fixed size, so it does not have to be borrowed, it is passed around as a literal. The complete text of the Bhagavad Gita is different depending on your encoding scheme, so you don't know how long it is. So you have to use some form of data structure to store all of it. If you have to use some form of data structure to store all of it, it has to be owned. It is owned by a line of code. There can only be one owner at a time. And when there is no owner, the information is dropped, it is freed, and it is no longer memory managed. That's the way to think of the ownership system. You will deal with this in time, and you will get better at it over time. And it's pretty cool, but it's definitely not as cool as options and pattern matching. So don't let people tell you the borrow checker is the exciting thing about Rust. They're wrong. Are we out of time? I think so, right? I think that's good. I will see you on Wednesday to start working on WC. You will all see each other on Friday to do whatever it is you're doing Friday. Is there going to be lecture, or are they going to work on stuff?
It's going to be mostly lecture.
Okay, it's going to be mostly lecture on Friday. Are you going to record?
Yeah.
Okay.